So today's topic is friction. So already you know that what is friction. So the friction is the component of the contact force parallel to the surface in contact is known as the friction, and friction is always works in the opposite direction of the motion. Suppose here is one object and the object is going in this direction, in this way, that is the direction of motion. There is a surface and the friction will work in the opposite direction, the force of friction will be in the opposite direction. This is the object. Now you can say the definition of the force of friction. The friction is the force which opposes the relative motion or the tendency of the relative motion between the two bodies in contact and acts tangentially along the surface of contact. Or in other words, you can say force acting on an object which opposites its motion or impending motions. That means it is going to happen or it is about to move, like impending motion to relative to the surface is called the friction. So I have given the examples of this, or is the in the picture you can also see how the friction is working. Now frictions are two types. There are two types. There are static friction and the kinetic frictions. So two types: static friction friction and kinetic friction. So first we'll learn about the static friction. So what is static friction? The force of friction which exerts counterbalance, which exactly counterbalance the applied force during the stationary state of the body is called the static friction. That means in this case the object will not move, but it's about to move, like this. It is moving, but it is, suppose there is a very big almirah in your home, and anyone tells that you just slide that almirah, you just make it some little bit of distance. Then you start to apply the force on the almirah and the surface and the lower surface of the almirah, and on the floor will apply the friction force in the opposite direction. But the almirah is not moving, but still the friction force is working in the opposite direction. That means this is the static friction. So in this case you can see that this in this block. In this block, consider the wooden block of weight is W, and as weight is W, upward direction the reaction force will be there, and it is resting on a, say, in the floor or tabletop. The weight of the W is balanced by the equal and opposite normal reaction, you can see. And now if you apply a force F in this direction, you apply a force, otherwise you will not be able to move. So as soon as the force is applied on the block, a friction force Fs is arising, pointing in the opposite direction of the applied force. You can understand this. Now the friction force Fs counterbalance the F, capital F. This will counterbalance this one, is called the static frictional force. Now this is balanced actually. So balanced means there will be no motion at all, there will be no net force acting on the object because these are balanced. So that is why you can write that in static friction R minus W is equal to 0 because it is balanced, and also F minus Fs is equal to 0, or Fs is equal to F, or you can write R is equal to W also. So this is the balance. So you can understand that the static force of friction is equal to the applied force of the body. Okay. Now what is the limiting friction? Limiting friction is that first I'll tell the definition. The maximum value of the static friction force which comes into play when the body is just going to start sliding toward the surface. to the another body is called the limiting friction of force. So I'm applying the force and that at a maximum value of the static friction, then after that the friction, static friction will not be able to and apply the force, and this will become unbalanced. Just before that one, that is called the static limiting friction. So the maximum value of static friction force which comes into play, what I told you now, when the body is just going to start sliding, okay, over the surface of another body, just going to slide. Remember this one. So now some laws of friction. What are the laws of friction? The direction of the force of limiting friction is always opposite to the direction in which the motion takes place or tends to take place. Okay. The force of friction acts tangentially along the surface of contact of two bodies. You know this one. The magnitude of the limiting force of friction, F, is directly proportional to the normal reaction between the two surfaces. You can write down this one. So F is directly proportional to R. That is what kind of relation. So limiting friction force is independent of the area of the surface. Remember this one. The friction force is independent of the area of the surface of contact of the two bodies as long as the normal reaction is concerned. Okay, constant. Sorry. So limiting friction force depends on the nature of the surface in contact. So remember, it is independent of the area of the surface. Okay, so that is the thing. Now next one we come to the sliding friction, kinetic frictions. So kinetic friction. So it's kinetic friction. Kinetic friction also in two types. One is sliding friction, another one is rolling friction. So in the rolling friction is much less than the sliding friction. You know, sliding friction is what? The force of friction which comes into play when one body slides over the another body is called the sliding friction. For example, the wooden block is pulled or pushed over a ground, then the sliding friction comes into play. So and rolling friction is that the force of friction which comes into play when one body rolls over the another body is called the rolling friction. So example that the some wheel or some kind of thing, football is rolling over a road, rolling over a ground, a rolling friction comes into play. The rolling friction is much less than the sliding friction. So this kind of knowledge, actually the concept of rolling friction actually help the human being to invent the wheels. Okay. Now the cause of the rolling friction. So when a body says the wheels rolls over the surface, it causes it presses the surface under this. Due to this pressure, the surface is depressed and a bump is formed in front of it, and therefore the body has to be pulled out of the depression to climb the bump while in motion. So this causes the rolling frictions. So this is the thing. Now here we'll draw the graph between the we'll plot a graph between the force of friction and the applied force. So very important graph, this one. So this is applied force. This one is force of friction. So this is the rest condition. That means this is the limiting friction. And after that it will come to in motion. So this will become the kinetic friction. Okay, this is motion. So you can understand from the graph that the limiting friction is always more than the kinetic friction. So question comes that a horse pulling a cart has to apply a greater force to start the cart and then keep the cart in motion. So why? Because when the horse applied a force to pull the cart in the beginning, the static friction force is also increased. So the horse has to apply a large force to counterbalance the static frictional force. As soon as the cart comes to motion, the static force of friction changes its kinetic to dynamic force, okay, of friction. Since the kinetic force of friction is less than that of the static friction, hence the horse has to apply less force when the cart is in motion. So same thing for the kinetic friction also, you can write that you can write F is equal to, in case of kinetic friction, it is same diagram. This is the object here. This is Fk. For first we'll do for static friction, same formula, static friction Fs. So you can write the formula Fs is directly proportional to R, or you can write Fs is equal to mu into R, mu s into R. So this mu s is equal to Fs, you can write Fx max, actually Fx max by R. R is equal to mg, this R, so you can write R is equal to mg. So this one is known as the coefficient of friction. It has no unit, it's just a number. Okay, so coefficient of friction is just a unit, it's a not an, it's a, so again in this same thing you can write for the kinetic friction also. So kinetic friction you can write Fk is equal to or you can write Fk is equal to like is equal to mu k into R. So mu k is the coefficient of kinetic friction. Mu k is equal to Fk by mg. R is equal to mg. So this is the for kinetic friction. Now next one we learn about the angle of friction. So what is the angle of friction? Angle of friction is in this block. Draw the diagram. So this block is on the table. It is applying a force, mg force in downward direction, reaction force in the upward direction. R is equal to mg. Applied force in this direction. And like this way, this is the force of friction working. F is the force of friction. Now there is a resultant force of this one, so it will create an angle here. This angle is known as the angle of friction. So what you can write from this picture, the angle of friction, write the heading also. So write the angle between the normal reaction and the resultant of the limiting force of friction and the normal reaction is called the angle of friction. So from here you can write tan theta is equal to F by R. So F by R is equal to mu s, that you also know, the tan theta is equal to mu into s. So coefficient of static friction is numerically equal to the tangent of the angle of friction. So next one we can learn this one. This is called angle of repose. Angle of repose. So suppose an object is sliding down from an inclined plane in this way. So object is kept in this way here. So first you have to resolve this one. So this is alpha, and the mass of the object will exactly work downward direction. So that is mg. Reaction force will work upward direction, that is R, and in this case this will be counterbalance because this is also alpha. So mg cos alpha, and this one is mg sin alpha, and friction force is obviously working in this direction here. So what is the definition of this one? The minimum angle made by the inclined plane, this is the inclined plane, with the horizontal surface, such that the body lying on the inclined plane is just as the verge of sliding down along the inclined plane is known as the angle of repose. So it is about to slide, it is not sliding, it is about to slide. If I increase a little bit, it will start sliding. So that is known as the angle of repose. So from here also you can find out F by R, you can say R is equal to mg cos theta, F is equal to mg sin theta, because everything is balanced, so object is in static. So F by R is equal to mg sin alpha by mg cos alpha, that means tan alpha. So F by R is equal to mu, also you can write mu S here. So coefficient of static friction is normally equal to the tangent of the angle of repose. So this angle is known as the angle of repose. So some kind of relation they can ask that this tan theta is the angle of friction, and this is called the angle of repose. So also you can say that angle of friction is equal to the angle of repose. If we equate this one, you will get angle of friction is equal to angle of repose. So next one, the last topic, the acceleration of a body sliding down in an rough inclined plane. So we'll do it here. So acceleration of a body sliding down in rough inclined plane. So what is this? The object is sliding down like this way. To resolve the components, friction force is there, a reaction force is working in this direction. So see, object is actually going in this direction with the acceleration a. So you can understand this one, this force is more, this force is less. So you can write from here that mg sin theta minus f is equal to m into a. Okay, so f is equal to mu into r. We can write mg sin theta minus mu r means what? Mg cos theta. Mg cos theta is equal to m into a. So will take cancel here. So a will be equal to and then you can take g common, g sin theta minus mu, this is a mu k, kinetic friction, mu k cos theta. So this is the acceleration produced by the object in the inclined plane, sliding down in the inclined plane. So g